We want to find the maximum rate of change of the function f of x comma y equals 4y to the fifth divided by x at the point 4 comma 1. So the first thing to remember here is the gradient of f is going to give us the direction of maximum rate of change of f at the point 4 comma 1, but to find the actual maximum rate of change, we'll need to determine the magnitude of the gradient of f at the point 4 comma 1. So again, for a quick review, the direction of maximum increase of f is given by the gradient of f at the point x comma y, while the maximum value of the directional derivative of f at the point x comma y, or the maximum rate of increase, is equal to the magnitude of the gradient of f at the point x comma y. So we'll have two steps here. We'll first find the gradient at the point 4 comma 1, and then find the magnitude of that two-dimensional vector. And again, the given function is f of x comma y equals 4 y to the fifth divided by x. But if we wanted to, we could move this x up to the numerator, which would change the sign of the exponent. We could write this as 4x to the negative 1 y to the fifth. And now we'll find the gradient of f, also referred to as del f. So we'll find partial of f with respect to x, then the partial of f with respect to y. So to find the partial of f with respect to x, we're going to differentiate 4x to the negative 1 y to the fifth with respect to x, treating y as a constant. So the partial derivative would be, we'd multiply by negative 1, so negative 4x to the power of, subtract 1 from the exponent, so that's negative 2 y to the fifth. And now to find the partial with respect to y, we'd differentiate with respect to y, treating x as a constant. So we'd multiply by 5, that'd be 20 x to the negative 1, subtract 1 from the exponent on y, which gives us y to the fourth. And of course, we could also express this as an x component of negative 4 y to the fifth over x to the second, and we express the y component as 20 y to the fourth over x. Either way, we now need to evaluate this at the point 4 comma 1. So now we'll find the gradient of f, or del f, at the point 4 comma 1. Let's go ahead and use this form here. So now we'll substitute 4 for x and 1 for y. So the x component would be negative 4 times 1 to the fifth divided by 4 squared. And the y component would be 20 times 1 to the fourth divided by x, which is 4. So simplifying, this would be negative 4 over 16, or negative 1/4. And here we just have 20 divided by 4, which equals 5. And now the maximum rate of change at the point 4 comma 1 is going to be equal to the magnitude of the gradient. So now we need to find the magnitude of our gradient at the point 4 comma 1. So this is equal to the square root of, we'd have negative 1/4 squared plus 5 squared. This would be the square root of 1/16 plus 25, or 25 over 1 if we want to find the exact value. The common denominator would be 16 here. So this is going to be equal to the square root of, our denominator is going to be 16, and for the numerator, 25 times 16 is equal to 400. 400 plus 1 is 401. And since the square root of 16 is equal to 4, the exact value of the magnitude would be equal to the square root of 401 divided by 4. Let's also get our decimal approximation. The square root of 401, right arrow, divided by 4. Now if we do not need the exact value though, notice how we could just enter the square root of 1/16, so 1 divided by 16 plus 25, and we get the same decimal approximation. So to 4 decimal places, this would be approximately 5.0062, which again is the maximum rate of change of f at the point 4 comma 1. Let's also look at this graphically. So here's a graph of our surface. We were given the point 4, 1, which is this point here in the xy plane. The second red point here would be the corresponding point on the surface. To find the z-coordinate of this point, we'd have to substitute the x and y values from this point into the function. And from here, we found the gradient at the point 4, 1, which is this two-dimensional vector here in the xy plane. This vector points in the direction of the maximum rate of increase on the surface from this point, but our goal is to find the maximum rate of change, which is the magnitude of this vector here. So the magnitude of this vector here is the value that we found as approximately 5.0062. Notice how I've also graphed the tangent line to the surface in the same direction as the gradient, which means the value that we found, the magnitude of the gradient, is also the slope of this tangent line to the surface, again in the same direction as the gradient. I hope you found this helpful.